So, welcome back. In the last few lessons, we were discussing about linear functions. So, we were on problem sheet number 21. So, we have some questions pending from these sheets. So, we talked about various scenarios that represent a linear function. So, one is direct variations, okay, where your output will be proportionate to the input. That is one scenario, okay. Another scenario is arithmetic sequences. Okay, the list of numbers or sequence of numbers where the difference between consecutive terms will always be a constant. Okay, that is another scenario. Another scenario was unit conversions. You convert foot to meter. You convert calories to joules. You convert inches, centimeter and inch. Conversion between centimeter and inch. Okay. So these are the very common scenarios of linear functions, and we were discussing questions in this. So we were on question number 4, I think 4. Yeah. So let's move on to question number 5. Okay. The common difference of the arithmetic sequence. Okay. See, if you have a sequence of numbers, the difference between the consecutive terms may not always be the same. Okay, if they are the same, we call them an arithmetic sequence. Okay, in this case, it's given that it is an arithmetic sequence. Okay, in the question, it's given that it is an arithmetic sequence, so we don't have to worry about anything. You just solve this question. You take difference between any two consecutive terms. Take the difference between any two consecutive terms, and you have the common difference, right? So you can take. So we call the first term as 1/8, the second term is 0, the third term is minus 1/8, the fourth term is minus 1/4. Okay. The common difference will be obtained by taking the difference between any two consecutive terms. So your A2 minus A1, your A3 minus A2, A4 minus A3, all this will be the same. Okay. Only if they are the same, it will be called an AP. It will be called an arithmetic progression or arithmetic sequence. Okay, you can call this an arithmetic sequence or arithmetic progression only if these quantities are the same. The difference between consecutive terms is the same. So in this case, to get the common difference, you just subtract this 0 minus 1/8. The answer is minus 1/8. Okay, I think there are two options. See, correct this option. So minus 1/8 is the answer. Or correct this answer as minus 1/4 because 1/8 is already there. Is that okay? The difference between consecutive terms came out to be minus 1/8. Yes. It's a simple question. Okay. I hope everybody has this sheet with you. This is not the assignment from the current week, but this is from the previous week. This is not the assignment from the current week, it's from the previous week. We have some pending questions, so we are doing that now. Is this fine? I hope everybody remembers arithmetic sequences. We have discussed it in the previous week. Yes. So let's go to the next question. The next term in the following sequence of numbers. Now see this sequence of numbers. It is not mentioned that it's an arithmetic sequence. Okay, it's not mentioned that it's an arithmetic sequence. You have to figure out the pattern. So in this question, you see that again, the numbers in the sequence are, the first number is 1.8, the second number is 1.3, the third number is 0.8, fourth number is 0.3. Now you see that the difference between the consecutive terms is negative 0.5. A3 minus A2 is again negative 0.5. Similarly, A4 minus A3 is negative 0.5. Okay. The difference between consecutive terms is negative 0.5. Negative 0.5. In other words, you keep getting next terms. You start with 1.8. To get the next term, you just add negative 0.5. Okay. So you get 1.3. Now to get the next term, what you have to do is you have to add negative 0.5. Okay. That is how the sequence is obtained. So going from this to this, you are adding negative 0.5. Going from this to this, you are adding negative 0.5. Going from this to this, you are adding negative 0.5. Now to get the next term, you have to add negative 0.5. So our answer will be 0.3 added with negative 0.5, which is negative 0.2. Negative 0.2 will be our answer. Okay. So in this question, it's not given that it is an AP. It is not given that it's an arithmetic sequence. It is not given that it's an arithmetic sequence. Instead, we figured it out. We understood that the difference between consecutive terms is always a constant. In other terms, you keep getting the next terms by adding a constant number to the preceding terms. Okay. You take 1.8, add, so 1.8 is the first term. Okay. Now keep adding negative 1.5 to the these numbers. You keep generating new numbers, right? 1.8, 1.3, 0.8, 0.3, and so on. So the next number in the sequence will be negative 0.2. Is that okay? Is that okay? Okay for everyone? Tell me. Yeah. The next question, please see question number 7. That's a very tricky one because, instead of numbers, they have given symbols. They have given variables. So next term in the sequence represented by 5a minus 1, 3a minus 1, a minus 1, minus a minus 1. Do you see a pattern here? Do you see any pattern here? Do you see any pattern here? See, you start with 5a minus 1, then you're going to 3a minus 1. Okay. So when going from 5a minus 1 to 3a minus 1, what really happens? You're reducing 2a, right? You're reducing 2 times a. Going from this to this, you're reducing 2 times a. Or you can say that you're adding minus 2 times a. You're adding minus 2 times a. Now, similarly, from the second term to third term, 3a becomes a. Again, the same trend, the same pattern. The same pattern. Going from 3a minus 1 to a minus 1, what really happens is you're reducing to a. Now, going from a minus 1 to minus a minus 1, what happens? Going from a minus 1 to minus a minus 1, again the same trend. Let's actually verify this. See, let's verify this. The terms in the sequence are, the first term is 5a minus 1. The second term is 3a minus 1. The third term is a minus 1. The fourth term is minus a minus 1. First term is 5a minus 1. The second term is 3a minus 1. third term is a minus 1, the fourth term is minus a minus 1. Yeah, now let's check the difference between these two numbers. Difference between these two numbers. So your a2 minus a1 is 3a minus 1 minus 5a minus 1. Do not forget to put a bracket. Do not forget to put a parenthesis. Okay. If you do not put a parenthesis, you're going to make a mistake. So this is going to be 3a minus 1 minus 5a plus 1. 1 and 1 get cancelled. This is minus 2a. Minus 2a. So as we mentioned before, going from a1 to a2, what really happens? You're subtracting 2a, or you're reducing the number by 2a. Okay. Now similarly, when you're going from a2 to a3, the difference between a3 and a2 is a minus 1 minus 3a minus 1. Now what really happens now? A minus 1 minus 3a minus of 3a minus 1. What happens now? This is a minus 1 minus 3a plus 1. 1 gets cancelled. Again, you have minus 2a. Now going from a3 to a4, let's see the difference. a4 minus a3. a4 minus a3. a4 minus a3. a4 minus a3 is going to be minus a minus 1 minus of a minus 1. Minus a minus 1 minus of a minus 1. So this is going to be minus 2a again. Why? Because this is minus a minus 1 minus a plus 1. So 1 and 1 get cancelled. You have 2a. You are left with minus 2a. So this is an arithmetic sequence. Why? Because the difference between consecutive terms is a constant. The difference between the consecutive terms is a constant. Okay. The common difference in this case is minus 2a. So starting with the first term, you keep adding minus 2a. Okay. You keep generating the next terms. Okay. Starting with the first term, you keep adding minus 2a. You keep adding minus 2a. You keep getting the next terms. Right. Now you are asked to find the next term in the sequence. So what will you do? How will you find a5? To a4, add minus 2a. To get a5, you add the common difference to a4. So this is minus a minus 1 plus minus 2a. So the answer will come out as, this is minus 2a. The answer will come out as minus 3a minus 1. Minus 3a minus 1 is our answer. Minus 3a minus 1 is our answer. Is that all right? Minus 3a minus 1 is our answer. Let me know. So instead of numbers, they have given us variables. But again, these are expressions. So, but difference between the consecutive terms happen to be a constant once again. Yes or no? Okay. Please let me know if you have any confusion. If you want further explanation, please do let me know. Hello, are you with me? Yes, okay. Is this okay? Let me know if there is a confusion, if you need further explanation. See, alternatively, you can do, see, during a exam like SAT, na, you don't have to worry about the numbers A. See, you can actually substitute some value for A and verify the answer. You can do that as well. What you can do is, say you can choose your A as 1. Choose your A as 1. So wherever there is A, you just replace it with 5. I mean, sorry, 1. Wherever there is A, you just replace it with 1. What happens to this? What happens? The 5A minus 1 term becomes 5 minus 1, which is 4. Next term becomes 3 minus 1, which is 2. Next term becomes 0. Next term becomes minus 2. So do you see the pattern now? Do you see the pattern now? Do you see the pattern now? The numbers are 4, 2, 0, minus 2. 4, 2, 0, minus 2 are the numbers. Do you see the pattern now? Yes, please tell me. Yeah. Now you can just verify the options. So in this sequence, tell me what will be the number? 4, 2, 0, minus 2. What will be the next number? What will be the next number? 4, 2, 0, minus 2. And what will be the next number? So you are just forgetting about A. You're just substituting some value for A and verifying the options. So what do you think will be the next number in the sequence? We have 4, 2, 0, minus 2, and the next number will be? See, you are subtracting 2, right? To get to the next term. Starting with 4, you keep reducing 2 to go to the next term. So after minus 2, the next term will be, what will be the next term after minus 2? What will be the next term after minus 2? Please tell me. What will be the next term after minus 2? Yeah, it will be minus 4, right? It will be minus 4. Now you just compare the options. There are 4 options. Okay. When you put A is equal to 1, what happens to each of the options? What happens to each of the options? That is what you need to check. The first option is 3A minus 1. That number is 2. This number is minus 3A minus 1, which is minus 4. This number is 3A plus 1, which is 4. This number is minus 3A plus 1, which is minus 2. Of course, this is your matching answer because the next number has to be minus 4. So this is matching. C is our matching answer. Okay, of course, we got C here as well. We got minus 3A minus 1. Minus 3A minus 1 is the matching answer. Okay, so we used a sneaky way here, sneaky approach here. Instead of actually finding out the answer in terms of A, you just take some value for A and then verify the options. We just verify the options. We just verify the options. All right. So the next question. The common difference for the data listed in the second column of the below table is. Okay, again, there is a table of numbers. You have to look at the second column only. So in the second column, we have to find the common difference. Okay. So common difference will be 208.4 minus 210.2. 210.2. So just subtract this 208.4 minus 210.2. The answer will come out as minus 1.8, right? Negative 1.8. Similarly, if you take the difference here, 208.4 minus 206.6, again the answer has to be the same because they are talking about a common difference. They are talking about a common difference, so the difference has to be the common one. Okay, it is minus 1.8. Is that okay? Tell me, yes. Yeah. Next question is, which of the following sequence is not arithmetic? So which of the following sequence is not an arithmetic sequence? See, the first sequence, what happens? Minus 4, 2, 8, 14, right? What really happens is you keep adding 6 to this, plus 6, plus 6, plus 6. This is an AP. Minus 4, 2, 8, 14. This is an AP. Minus 4, 2, 8, 14. This is an AP. Minus 4, 2, 8, 14. Okay. Why? Because the difference between consecutive terms is 6. Or in other words, you keep getting next terms by adding plus 6 to the first term onwards. Okay. The common difference is 6. In the second case is B. What is the situation here? We have 9, 4, minus 1, minus 6. So what really happens is you're adding minus 5 here. You're adding minus 5 here. You're adding minus 5 here. This is also an arithmetic progression, arithmetic sequence. This is an arithmetic sequence, right? This is an arithmetic sequence, right? Yeah. Next one. See this 2, 4, 8, 16. Oh, it's very clear. This doesn't follow that pattern because you add 2 here, but here you're adding 4. Here you are adding 8. Okay. Right? Is this an arithmetic sequence? Is this an arithmetic sequence? Is this an arithmetic sequence 2, 4, 8, 16? No. Can somebody tell me what the sequence is called? Have you come across this? Have you come across this? Yeah, it's geometric. It's called geometric. The ratio of consecutive terms is a constant. Okay, it's called a geometric sequence. Anyway, so the next one, 1 over 3, 1 over 1 and 1 over 3, 2 and 1 over 3, 3 and 1 over 3. Again, obviously it's an arithmetic sequence because you keep adding 1 to this, keep adding 1 to this, keep adding 1 to this. All right. So question talks about the one which is not arithmetic. So the answer is C. Yes. So we'll move on to the next question. The speed of the sound in air at room temperature is 346 meter per second. Which of the following function could be used to describe the distance in meters d that the sound will travel in air in t seconds? Of course, speed, distance, and time. You need a relationship connecting them. Okay. The speed is a constant quantity which is given to be 346. So your speed is 346 and that is going to be a distance over time. So d is equal to 346 times t. D is equal to 346 times t. D is equal to 346 times t. Is it okay? So in 1 second, it will cover 346 meters. In 2 seconds, it will cover 2 times 346. In 3 seconds, it will cover 3 times 346. In 4 seconds, it will cover 4 times 346. Okay. That is what this relationship is saying. That is what this relationship is saying. Okay. Cool. Now we are moving on to problem sheet number. This was our sheet number. This was 21. We are going to 22. Okay. Please take problem sheet number 22. We are moving on to problem sheet number 22. So this is what we discussed in the previous class. Okay, we were discussing about the significance of M and C. Okay, in the previous class, we were discussing about the significance of M and C. Okay, we said that M gives the rate of change of Y with respect to X. C gives the initial value of function, initial output for 0 input. Okay. Now let's see the questions. So we have question number 1 here. The table above shows some values of X and their corresponding values of Y. Which of the following equation shows a possible relationship between X and Y? Possible relationship between X and Y. Now, this is a very easy question. You don't have to do any math at all. Why? Because the relationship between X and Y is very clear here. Do you see the pattern here? Do you see the pattern here? Do you see the pattern here? So there is a correction here. This has to be 8, okay? No, it's not 8. It has to be 6. It has to be 6. Otherwise, it doesn't make sense. Do you see a pattern here? Do you see a pattern? Your Y value is obtained from X value by adding 3, right? Your y is nothing but your x value plus 3 every time. You see the pattern? You see the pattern here? Your y value is obtained from your x value by adding 3. Hello? Hello? Are you with me? Yeah. So one way to figure it out is you just look at the relationship. You're adding 3 here. 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 So in general, to get y, you add 3 to x. That is what it says. Your y is x plus 3. So this was possible because the pattern was very clear to us. It was obvious. Okay. Otherwise, how will you do it? 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 So that is what I'm talking about. See, first of all, you have to observe that for constant changes in x. So when your x values change by 1, 1, 1, 1, the difference in y is also a constant. It happens to be plus 1, plus 1, plus 1, plus 1. That is the first thing you need to observe. You have to observe that for constant change in x, the change in y is also a constant. Okay. It has to be the same. It need not be plus 1, plus 1, plus 1. It can be plus 2, plus 2, plus 2, plus 2. That is fine. But it has to be the same. Yeah. Now, with this information, you can get, you can understand that this is a linear relationship. This is a linear relationship. Okay. That's the linear relationship between y and x. That's a linear relationship between y and x. That's a linear relationship between y and x. Now, a linear relationship can be written as y is equal to mx plus c. A linear relationship can be written as y is equal to mx plus c. And your m value is nothing but change in y over change in x. Change in y over change in x. So change in y is plus 1, change in x is plus 1, which is 1. And your c value is the initial value. Initial value means what? The output when input is 0. Okay, 0 input out. The output corresponding to 0 input is your c value. The output corresponding to 0 input is your c value. So c value is this number because that is the output corresponding to 0 input. So this is c. C is equal to 3. So from this you have y is equal to mx plus c. So 1 times x plus 3. So you have y is equal to x plus 3. This is the general process, general method to do it. But it is not always the case that you have to go ahead with this method. If there is a pattern which you can easily observe, then the answer is very easily obtained by looking at the options. So y is equal to x plus 3 is our answer. Is that okay? Okay for everyone? Yeah. Next question. Your school volleyball team is ordering new jerseys. there is one-time setting up fee of $75 charged by the tailoring company. Each jersey costs $19.5. Which of the following best describes the total cost C for ordering uniform for N players in your team? Okay. So there is a one-time setting up fee. Okay. So one uniform is going to cost $19.5. Two uniforms will cost 2 times 19.5. Okay. If there are N players, the cost of uniform will be N times 19.5. Along with that, you have to add a setting up fee. Okay. There is a one-time setting up fee that is going to be $75. So this is your total cost. Okay. So your total cost is going to be 75 plus 19.5 times N. Of course, this is a linear relationship between N and C. Okay. There is a linear relationship between N and C. This is a linear relationship between N and C. This is of the form y is equal to mx plus c. Now tell me, what is the significance of 75 here? We discussed this in the previous class. The significance of 75 is the output value when the input is 0, or the initial value of the output. Okay. So even if there are 0 players, the setting up fee is there. I mean, of course, not in practical sense. Theoretically, even when n is 0, the 75 will be there. Okay. Or you can say that the value of output when the input is 0. So that is 75. That is the significance of 75. What is the significance of 19.5? What is the significance of 19.5? 19.5 is the rate of change. Okay. When you add one more player, when you change your n by 1, okay, when change in input is 1, what is the change in output? So when you add one more player, the price goes up by $19.5. So that is the significance of 19.5 here. Okay, that is the significance of 19.5. I hope that's clear. So let's go to the next question. The table below shows some related values of Iqbal's walking speed and his corresponding pulse in BPM as indicated by smartwatch on his wrist. There is a linear relationship between Iqbal's speed x and his pulse f of x. Okay. Which of the following function describes f of x? So the question clearly says that there is a linear relationship. Okay. So if you call this as x and this is f of x, your f of x is in the form of mx plus c. Your f of x is in the form of mx plus c. Now, our idea is to find the expression for f of x. Our idea is to find the expression for f of x. Now, how can we do that? It is clearly given that it's a linear relationship. So, in a linear relationship, you know that your rate of change is m, and that is given by delta y over delta x. Delta y over delta x. Delta y over delta x. So take some change in x and take the corresponding change in y. For some change in x, what is the corresponding change in y? Have a look at it. Okay. So change in y will be 81 minus 72 when the change in x is 5.4 minus 3.6. Your change in y is going to be 81 minus 72 when corresponding change in y is corresponding change in x is 5.4 minus 3.6. So please calculate this. This is going to be 9 over 1.8, which is 5. So this is going to be 5. Your m value is 5. Your m value is 5. Now for C, actually, C is nothing but the output value when the input is 0, but such a column is not, such a row is not given, such an information is not given here. So we have to look for other approaches. So what we are going to do is, we have f of x is equal to mx plus c. We have f of x is equal to mx plus c. Okay, your m value came out to be 5. Your m value came out to be 5. So your f of x will be 5x plus c. The m value came out to be 5x plus c. Okay. Now, how will you find the value of c? You can choose any ordered pair from the table and get the value of c. Okay. You can choose any ordered pair from the table and get the value of c. I'm sorry, I'm not feeling well right now, so I'm winding up early today. We can meet in the next class. Maybe I will be able to compensate it sometime later. Okay. I'm sorry. We are winding up slightly early today. We'll compensate sometime later. Okay.